In the last video, we had written out a formula for the runtime of the MergeSort algorithm, which I'm going to be rewriting here. I wanted to continue off that video, but I had to stop recording for the night, so I'm going to have to restart just by writing it here. So this is the formula that we found with MergeSort, right? And what were these two times over here? Well, this thing over here, this term, just means the runtime of MergeSort. Runtime of MergeSort. Okay, simple enough. This over here was breaking it down into subproblems. Once again, simple enough. We saw how that was. That was like the recursion happening. And this last one over here, the C of n, was the merging, right? The merging is going to take time, right? We saw that it has to put it all together. It has to put everything in order. That's going to take some time as well. All of this together will give us the runtime of the MergeSort algorithm. But the problem is we have T of n written in terms of T of n over 2. That doesn't tell us anything. So in order to actually get some numbers here, which is what we want some real numbers that we can work with, we're going to have to go through a few rounds of this recursion in order to find a pattern. And this is going to seem a little bit strange, a little bit awkward at first, but you'll understand the process as we go through this. And we will do this with some other algorithms in this series, so you'll be able to get a hang of it. So in order to solve T of n here, we will need T of n over 2. So what exactly is T of n over 2? I don't want that color. I've already used that color. Let's go with yellow. T of n over 2. Essentially, we are going to write T of n, which is the one we have up here, and every time we see an n, we are going to divide it by 2. Simple enough. And then we are going to substitute that back into the equation. So this is going to be weird, but let's go ahead and do it. So this 2 over here, well, there's no n attached to that, so we'll just go ahead and write the 2. Now we're going to go ahead and write this T of n over 2, but now we see we have the n, so we will need to divide that by 2. So we will have T of n over 2 times 2, which is going to be 4. So T of n over 4 plus C n, and we have an n over here, so we'll have to divide that by 2. So just using logic, we can see how we get from T of n over here to T of n over 2. This one simply has the n's divided by 2. Now what we can do is we can go back into the original equation, the T of n equation, and now we can go ahead and actually substitute the T of n over 2 here with what we have down here. So what we're going to go do is we will keep the 2, and I'll go ahead and make sure everything matches up, and I'll put arrows so you guys see what's going where and what's coming from where. So now we're actually going to have a bracket here, and we will write this whole thing that we have in here. 2t n over 4 plus cn over 2 plus cn. Now let's go ahead and match all this up. The cn out here is just coming from down here. Nothing's changed. The 2 in front is going down here. But now this whole thing over here, let's get a new color. This T of n over 2 that we had in here was down here, right? We went and we solved it, and then we took all of this here and we plugged it in this little thing over here in these brackets. I guess I should put from the brackets here. Right there. So we had that first step. Is that enough though? It's not going to be enough. We will need to go through it one more time. One more time, it's going to start to show us a bit of a pattern. So let's go ahead and actually simplify this. I should probably have done that and clean things up. So now we will have T of n is going to be 4t n over 4 plus, what is this going to be here? Well, the 2 is going to cancel 2 here. So essentially, we're going to have plus cn plus cn. If you want to simplify that even more, 4t of n over 4 plus 2cn. Remember that c is a constant amount of time. It's a constant amount of time that's taking for us to do those mergers. It's whatever that factor is going to be. So to go one more step, what do we need to do? Well, we have T of n written in terms of T of n over 4 now. Essentially, we'll do the exact same thing. We can take the one that we had before, which is T n over 2, the one we had up here, and we can go ahead and draw that down here. We can go ahead and just divide wherever we see the n, we'll just divide it by 2 again, right? So we're going to go ahead and, or we could have taken the initial one and we can divided it by 4. It's all going to work. So now we'll write T of n over 4. Now we can go up and look at that one that we had here. not that one. We had this one up here. So we're going to keep that 2 in front. That 2 is not harming anybody. It's going to stay there. But now we're going to have t of n over 8, right? Because the 2, we're dividing that denominator of 4. We're going to essentially be multiplying that by the 2, right? Because it's also going to be a denominator. And they're going to come out to 8. And we're also going to have to put another one in here with the c of n over 2. So we can put that plus cn over, now it's going to be over 4. And now what we have to do is we have to go back to the t of n. This is our t of n right now. So I'm trying to get different colors here so we don't get too confused. So this is the t of n that we're going to be working with now. So let's go ahead and we have them down here. So we'll have 4. Now we're going to be replacing that t of n over 4. So we're going to go ahead and write this one that we have down here. 2t n over 8 plus cn over 4 plus 2cn. And we will go ahead and we will simplify that. This will be 8tn over 8 plus, this is just going to be cn plus the 2cn. Well, we can go ahead and put those together. So now we have 8 plus 3cn. And these are, of course, our t of n. This is the top level, right? So what was the purpose of doing all that? Well, do we see a pattern that's now forming? We have certain values here which are going to keep changing by, I don't want to say the same amount, but there's going to be a pattern between the changes. We notice this first number out here is going to be changing. We notice the denominator over here is going to be changing. And we notice this coefficient over here is going to be changing. So based on each time we pass through, how much are they going to be changing by? That is essentially going to be the question. Well, this first one over here, we saw that it went from 2 to 4 to 8. To go from 2 to 4 to 8, well, that means we have 2 to the power of something, right? That is how it is going up. So we can essentially replace this first term. It's going to be 2 to the power of k. Now, what about this term that we have down here? Well, we also know it's also following the same pattern. It started off being n over 2, and then it was n over 4, and then it was n over 8. So this 8 over here is also going to be 2 to the power of k, but just for the sake of it, I will write this as n over 2 to the k, just so we don't get confused here. So we have 1 over here, we have 1 over here, and then what is this value over here? Well, this one's just going up by 1 each time. So this goes from 1 to 2 to 3. That one is simply going to be k. Now we are going to go ahead and write out the solution with these values that we have, right? I guess you can call it general solution if you want, but it's just going to be a solution that will show you exactly what pattern you're going to expect. And this will be t of n will be written as 2 to the power of k, which we'll have in front, multiplied by t to the n over 2 to the k, plus k c n. Simple as that. Now, if we want to take this even further, right? What exactly is the big O runtime of what we are looking at, right? If we want to go to the next step, the big O runtime, which I'll probably acknowledge this a bit more in the next video. This one is running on a little bit. I think actually that's what I'm going to do. I'm going to get to this in the next video. We'll leave it at that, and I'll talk about the big O in the next video of what we just wrote. But this is how we will solve the recurrence that we had to get a formula which will accurately reflect the pattern that we had. I'll see you in the next video.